Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Saya ucapkan kepada pensyarah statik BNP 10102 iaitu teknologi Dr. Fatimah binti Muhammad Yusof. Saya wakil daripada kumpulan 5 grup statik kami akan membentangkan projek kami yang bertajuk Analysis of Equilibrium Force on Seesaw Mechanism. So these are the group members of group 5 static. My name is Muhammad Rashida bin Yusri, matrix number N220127. And next is Muhadir bin Buniman, CN220094. Next, Muhammad Zulkarnain bin Al-Hazak, CN220136. Next, Farah Sabrina binti Rafidi, CN220109. And lastly, Nofatin Diana binti Abdul Khalid, CN220232.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Buniman. So today I will present about the introduction for the static. Static and the real application are highly interrelated. The application of static is very broad. It gives a view of how the force and bodies act and react to one another. In engineering, static is used in the analysis of structure, for instance in architectural and structural engineering. Engineering static is the gateway into engineering mechanics, which is the application of Newtonian physics to design and analyze object, system, and structure with respect to motion, deformation, and failure. In addition to learning the subject itself, you will also develop skill in the art and practice of problem-solving and mathematical modeling skill that will benefit you throughout your engineering career. Static is an important concept in engineering technology since it serves as the foundation for structure design. Static is the study of structure that are at rest under static equilibrium condition to ensure equilibrium, as well as the force acting on them. The static analysis method provides means to analyze and determine both internal and external force acting on a structure. So thank you.
Assalamualaikum, my name is Nofatin Yana. So I would like to present our objective of our project, which is to provide a simple engineering solution to seesaw and analysis, and to extract and create such a simple solution based on the result.
This is the theory for our project, which is moment. The moment of a force is the perpendicular force acting at a distance and cause an object to rotate. The moment of a force is a measure of its tendency to cause a body to rotate about a specific point or axis. This is different from the tendency for a body to move or translate in the direction of the force. In order for a moment to develop, the force must act upon the body in such a manner that the body would begin to twist. This occurs every time a force is applied so that it does not pass through the center of the body. A moment is due to a force not having an equal and opposite force directly along its line of action.
Hi, saya Farah. So I want to explain about moment. When a body is balanced, the total clockwise moment about a point equals to the total anti-clockwise moment about the same point, according to the principle of moment. So the equation for moment is force times with the distance from pivot. So the unit SI untuk moment adalah Newton meter ataupun Newton cm. This is the diagram that shows the state of equilibrium. The blue box on either side of the seesaw are exactly the same in weight and height. In fact, they are the same model. In a result, the seesaw stays level. The center of the seesaw is called the fulcrum, seen here as a triangle, and this is where the beam that the box rests on tilts backwards and forwards. However, because of the state of equilibrium, they remain completely still. The weight of the box is called the effort. So through a principal moment, we can conclude that both objects are balanced. The total clockwise moment about a point is equal to the total anticlockwise moment about the same point. This is called the principle of moments. Total clockwise equals to the total anticlockwise of moment.
So from the situation 1, we have the added box with the same mass on the box on the right side, so which will increasing the force of the right side to 40 Newton. So, and I have drew the free body diagram to clearly state the point so that I can count it. And we know that the formula of the moment is equal to force times d, which is d stands for distance, and for right, moment is equal to 40 times 2. Why 40? Because because they are the added box on the blue box. So 40 times 2 equal to 80 Newton meter, and clockwise, positive clockwise. And for the left side, moment is equal to Fd, the formula, and I have counted moment equal to 20 times 2 equal to 40 Newton meter, which is anti-clockwise and negative. And for the conclusion for these situations, the situation is not in equilibrium. And for the second situation, we have two added box and have been given the force. We can see clearly on the right side, the added box are actually the same size as the original box. And from the left side, we can see that the box is maybe 2 times larger, but the force has been given 65 Newton, so it's actually not 2 times. Okay, and then we continue with the free body diagram. I've drew it so I can clearly state the point to count the moment. So the moment is equal to Fd from the left side. I've got moment is equal to 65 times 2 equal to 130 Newton meter, which is anti-clockwise from the middle, so it is negative. So for the right side, we have count early, which the moment is equal to 80 Newton meter, positive and clockwise. And from here, we know that the left side will be fell out, and the right side will going upward. And for the conclusion for these situations, the situation is not in equilibrium. Okay, now so we move on to the last situations, where we try with a little modifier, where we try to put the fulcrum closer to the left load. So in this situation, we assume that the left load is the load with the bigger one, and the right load is with the load with the small one. So, and the free body diagram have been reviewed. So the question has said that the situation falls in the equilibrium, which means that it is balanced on both sides. So from the principle of moments that we know, the total clockwise moment about the fulcrum is equal to the total anti-clockwise moment about the fulcrum. Then we calculate each individual moment first. So first of all, for the anti-clockwise moment, the perpendicular distance from the fulcrum is equal to d meter. That has been given in the questions. D meter, so the force is 10 Newton. So the anti-clockwise moment, F times D is equal to 10 Newton times D meter equal to 10 D Newton meter. And for the clockwise moment, the perpendicular distance from the fulcrum is equal to 1 meter, and the force is equal to 20 newtons. So we just count the clockwise moment. F times D is equal to 20 Newton meter. So from the formula that we have known, the total clockwise moment is equal to the total anti-clockwise moment, and you can see on the equations 10d is equal to 20. So now we can find the distance from the fulcrum D to the right side load, where d is equal to 20 over 10, and we got the d is equal to 2 meter. So in this situation, the situation is in equilibrium.
So the conclusion of our project is, when the object was in the state of equilibrium, it can be said that the object was static and no movement at all. However, it still have its force. Having an acceleration of 0 meter per second square does not mean the object is at rest, and it also can be in motion or continuing in motion with the same speed and direction. This can be proved by the extent of Newton's first law of motion. That's all from us. Thank you.